Okay, to start off, I need y'all to find a couple of your AMI assignments. So on Tuesday, I had you do the limits review. So if you printed that out, great. If you did on notebook paper, that's fine too, but you need to get out whatever you had worked on from Tuesday last week on AMI. And then Thursday, I had you do difference quotient notes and difference quotient practice 1. The first thing I want you to do is to check your answers to difference quotient practice 1. So I'm about to put those answers up on the screen. And then if you missed some of those, you need to retry them, and if they're still not working for you, then you will need to ask for some help here. This is the answers to the difference quotient practice 1. And of course, if you miss one, jot the right answer out to the side. And again, you'll have some class time to work on that, retrying it, and then I can go over it with you if I need to. But okay, and then everybody done with that? You'll need to hurry. We're late. Okay, while everybody finishes up with that, the handout that you guys picked up today, you may not need it all. It's actually the same limits review that I assigned to you on Tuesday. So some of you probably printed that out already, or some of you already did it on notebook paper. I went ahead and gave you a hard copy because, to be honest, I really just ran those copies off before the snow and ice hit anyway, so I was just going to throw them away. So if you did do your work on notebook paper and you don't like it being on notebook paper, you're welcome to copy it over, but you don't have to copy it over for me. That's just an option. If you printed off your work and so you already have a copy that looks like this, you're welcome to not use today's handout if you don't feel like you need it, or if you want to use it as an opportunity to maybe re-practice a couple of the questions you know you missed the first time. That may not be a bad idea too. But we'll come back to that. So the next thing we need to do is I need y'all to look through your review and see which question types you were most concerned about for the test. So truthfully, if we hadn't had all the snow and ice and stuff, we probably would be testing today. But just to be completely fair and make sure you guys had time to ask questions and all that kind of stuff. Of course, we would have done them in a different order too. If we'd been in class, we would have done a difference quotient on Tuesday and then a test review on Thursday, and then we would have tested today. But just to kind of get everything back in order here. But we will have our test on Thursday. So looking at the front page, this is the type of skill that we did the first day, reading a limit, left limit, right limit, and both limit from a graph. So either of those two you're concerned about, you want me to go over either one of those again? You guys are okay with this one? Okay. Then start looking through page 2. I think page 2 is the hardest because it definitely is testing the most amount of skills. Limits from piecewise functions, limits from tables, limits that work with just direct substitution, some limits that give you 0 over 0, and you got to do some work to get to direct substitution, like conjugates or trig identities or complex fractions or factoring. So when we did this stuff, we got to focus on just 1 or 2 of these a day. But of course on the test, they're going to be scrambled up just like they are on page 2. So again, I know you guys have already done this, or you were supposed to already do this, but I need you to look through there and see which ones you're concerned about, because you should expect all of these type on the test. So this is my chance to help you. Yes, limit is what y value is it approaching, and not the point. So the most common mistake, and I know I emphasized this on day 1, but for some reason this is just always something that's hard for students to accept. Like if there was a point here at 3,2, that has nothing to do with these questions at all. Limits don't care. Oh, well, I guess only this one's about x approaching 3. But limits don't care what the y value is at that point. It's not asking about a point. It's asking what y value is it approaching. It's approaching -4 from the left, -4 from the right, so the limit's -4. In fact, sometimes it's a good idea, if your question's just a limit, you can just completely cover up that, and then you can't even see where the point is or if it exists, because it doesn't matter. Your answer is still going to be -4. Does that answer your question?
So what would the first one be?
5 from the left, -4. You just need to know that this means just from the left only, or just from the right only. Okay, questions on page 2? Number 8. Okay, so in all these question types, you should be starting off with direct substitution. Hope that you get a number, and on like 2 of these, I think you do get your answer. So on your test, 1 or 2 of these will probably be just direct substitution. But then occasionally you're going to plug in this number, this direct substitution, and you get 0 over 0. And this is where we have spent the bulk of our time on, so you will certainly see some questions like this. So you've got to have a list of things to consider, ways to simplify this. So the first day we did factoring, but none of this looks like factoring. Second day we did conjugates and trig identities. Well, I don't see any trig things, so it's probably not trig identities. The third day we did piecewise functions. This is not a piecewise function. And complex fractions. This is not a complex fraction. So within all that, the only one that I said that would work is conjugates. And I know that because of the square root. So you want to multiply the top and the bottom by the same thing. So that way it's like you're multiplying by 1. And you specifically want it to be the conjugate. Conjugate means you switch this middle sign only. So essentially what we're doing is we're using some algebra, some fancy algebra to make this stuff look different so that something cancels and then direct substitution will work. So in the top here we've got a x minus 2 times this stuff. And in the bottom we've got this stuff times this stuff. 2 terms times 2 terms. Most people are going to call that FOIL, although FOIL is really just distributing. So you do 1 times 1. You could do the outer part of FOIL, but the inner part of FOIL is going to cancel it out anyway, so I'm not going to write the outer or inner part. That always happens when you multiply something by its conjugate. And then the last part of FOIL, the square root of 3x minus 5 times the square root of 3x minus 5 would be 3x minus 5. But 1 is positive and 1 is negative. So what I did from here to here is I multiplied my fractions. Okay, well I need something to cancel before direct substitution is going to work, so I guess I could try to maybe distribute this negative. I could combine like terms, and maybe then I could factor out a 3. So I don't see that it's going to work out that way right away, but I got to do something, so I did that. And then this looks like this is going to work, because x minus 2 is going to cancel out x minus 2. And now that something is canceled out, direct substitution should work out fine. Plug in 2 into what's left over. There's only a negative 3 in the denominator. Plug in negative or 2 up here. Looks like we get 2. As long as you don't get 0 over 0, then that should be your answer. So it's not like your test is going to have 5 different conjugate questions, but you really should expect at least 1 or 2 of those. Yes, Julia?
Can you do number 13?
Okay. Any other questions about 8 before I move on? The main thing you need to get out of this question, again, it's not going to be the exact same question on the test, but if you know you get 0 over 0 and nothing else that you do works, you just need to have somewhere in your brain that, hey, maybe multiplying by conjugates will help. That's all you could do on that one. Okay, so 13 is going to start and end the same way. You should start off with direct substitution. Unfortunately, you get 0 over 0, so we got to make this look different, get something to cancel, and then finish with direct substitution. It's different than the last question in that this is not a conjugate question because there's no square roots here. I guess you can factor out a 2 out of the bottom. You don't really have to do that right away, but you're going to have to do that eventually. But if you just do this, again, you get kind of stuck, and that's okay to get stuck for just a minute. But there's that list of things that we've done that you need to consider. So I'm not going to read them all out to you again, but specifically on this one, on one day we did conjugates and trig identities. So at some point you need to say, well, wait, cosine squared is the same thing as 1 minus sine squared. And one of the very few things you still need from last semester, the first Pythagorean identity. And we've actually seen this same question a couple times now, so I think it's a little bit easier for you guys not to fall into the next trap, and that you guys want to cancel these, but you can't cancel out terms, things being added or subtracted. You can only cancel out factors, things that are being multiplied. So your last hurdle here that's unique to this question is realizing that this is just a difference of two squares. You've got a 1 being squared on the left, a sign being squared on the right, and difference of two squares is always a plus and a minus. So the two highlighted steps are the big unique things about this question. Thinking about changing the trig function with a trig identity and still making sure that you don't cancel these but instead factor it. But now it's going to finish just like all the others. Something cancels and then direct substitution. I guess you still have to know unit circle, but that's a given. So yesterday, this was definitely, I think this was asked in all three of my other classes, so this seems to be one that y'all struggle with a little bit more. Is there anything more specific about it for anybody? Okay, what else you got from page 2? And again, same thing. There's not going to be like 5 of these on the test, but you should expect 1 or 2. That was half of one of our days. So. Okay, if there's other stuff, that's fine. You'll have plenty of time to ask here in a bit. But what about page 3? Page 3 was making sure you remember your horizontal asymptote rules, knowing what a horizontal asymptote is, so that you can work questions like 17, 18, and 19, and or 20, I guess. 16 and 20 are very similar questions, actually. So any of the infinite limit stuff you want a review on? Okay, then after that, there's really 2 more topics, continuity and difference quotient. So 21, make sure you know the 3-part definition of continuity. You do need to have that memorized, because if you're to justify why something is not continuous or to justify why something is continuous, you have to be using this 3-part definition. If you just try to explain it in words, it doesn't usually work out that way. Generally, you guys open yourself up to some counterexamples. Yeah.
For like explaining the definition, do we need to say like limit must exist, point must exist, points must be the same, or do we have that like actual math?
If your words mean the same thing, so like I think one thing you said was the point exists. So like to me, that's the second part of the definition. So if you said there is a point at x equals -5, that's the same thing to me. The problem is, especially the third part. Well, the first part, if you said the limit exists, instead of saying this, I guess that's okay too. But I really worry that if you try to explain part 3 in words, that you're not going to do it completely without any like holes in your explanation. You'd have to, and I'm not saying that it's not possible, but it's a whole lot easier to just say the number that it's approaching on the left and the right, the limit, is equal to what the point is. It's a whole lot easier to say that than to write a few sentences and not have any holes in your logic. So. But that's just to prove it's continuous. If it's continuous and you have to prove it, you have to state all three parts of the definition. If you're proving something is not continuous, you just need to say one of them that doesn't work. You don't have to list everything that doesn't work. Showing that one doesn't work is sufficient. Okay, so reminder on the definition, or question 22, why this is continuous or not continuous. 23, why that's continuous or not continuous. Or 24, why is this continuous or not continuous. Any of those parts? I'm feeling like maybe we should have just quizzed today. Y'all don't seem like you need very much help. Okay, then the last part, and again, there's plenty of time if y'all do find something later. I realize I could be moving on too quickly. So the most recent one that you did was the difference quotient. So you need to make sure you know what the difference quotient is. And just like your practice one, either be able to do that to a polynomial. This is definitely the most common type, a radical or a rational. So I don't remember how many of these we put on the test last year, and I'm not in charge of putting together this year's test, but I would say that if there was only one of these, it's probably going to be this type, because it's the most common type. If there's two of them, it's probably going to be this one and one of these other two. So I don't know. The person putting the test together may put all three of them on there. I just don't know. But this one is the most important. So any of those three types you'd like me to go over? 26? Okay, so as I said, you have to know the difference quotient for these. It's basically a formula that tells you what to do. So in our video, I show you where this comes from. You don't have to know that for our test. I just was showing you that so it didn't feel completely random. But you do have to know it, and you do have to know how to apply it, and you have to know how to simplify it. So here's what you got to know. This is like the formula. The applying it, this in red means everywhere there's an x, you're going to replace with an x plus h. This in purple just means you're going to subtract away the whole function. And it's inconvenient because you don't need it till the end, but you do have to keep up with the over h. And those first two steps are true whether it's a polynomial function like 26, a radical like 27, or a rational like question 28. What's different is how they're going to simplify. A polynomial, this one should probably be more familiar to you guys on how this one simplifies. But at some point you need to square this, and this is the most common mistake. So I'm going to slow down for a second here. This, oh, it's not squared anymore, becomes this. Too often, or just an easy mistake to make, is for y'all to say x plus h squared is x squared plus h squared. Now, I don't know if this was true, or I don't know if it's still true, but one of our teachers that was here like 8 years ago or so used to teach a program called iPrep, which was like an ACT practice course over the summer, and he told me that this concept was on the ACT every single time, and this was always there as a wrong answer. That's not how you do that. X plus h squared, you actually have to FOIL it out. So that's where I'm getting 2xh's. So make sure you don't fall into that trap. But then otherwise it's just distribute and combine like terms. And with that, it's kind of messy and it's kind of long, but distribute the -4, distribute the negative. Oh, sorry, I don't think I didn't make y'all do these questions yet, did I? Yeah, that's, so you guys will need to do that today. But it's good that we're going over this one because the answer key has the wrong answer on this one. So then at some point you got to say, okay, I FOILed this, now I need to distribute the 2. But why did I do this in this order? Why did I square it first and now come back and multiply by the 2? Why didn't I just distribute the 2 and then FOIL?
Order of operations.
Very good, order of operations. So I couldn't have done that even if I wanted to. So now it doesn't really matter where the stuff come from, so I don't know why I'm really keeping it colored. But longer questions, more places to make a mistake, which is how I have a mistake on the answer key. Just because you can FOIL, just because you can distribute, just because you can combine like terms, if you're not careful, then you can still lose some points. Now for us, it's not that big a deal. On your test, of course, I know you're aiming for 100, but you know, I'll give you partial credit. But I can tell you that this is like almost to a T how calculus goes. Like, you can understand the calculus concept, you can understand the algebra behind it, but when it's 1, 2, 3, 4, 5, 6 steps, it's just a lot harder to do that many steps without making a mistake, and that's where it can get frustrating sometimes. But if I combine my like terms, pretty much everything goes away except 3 things in the top that all have an H. So I'm going to factor that H out. And your last step on all of these question types, times 8 divided by H. And this is what's basically fixing the 0 over 0 for you. We're not doing the limit part on this. You will in calculus. But because these cancel out, now you could plug in 0 for H and you would have what's called a derivative. So this is what we'd be looking for as an answer. 4 x's, a minus 4, and 2 h's. So other than being kind of long and lots of places for careless mistakes, the arithmetic on this is not too bad. FOIL, distribute, distribute, combine like terms, distribute, combine like terms, factor out an H, divide out the H. But all of them end by dividing out the H. So that's actually kind of good because it gives you something to aim for. Again, even if you didn't think you needed help on this one, please make sure you jot this answer out to the side, because the answer key online does not have the correct answer on that one. I think it has a 1 H instead of 2 H's or something. Okay, while this one's up, any further questions about what I did? What's the most important part of this whole problem? What would be the worst thing to forget about this? More important than order of operations.
Forget the H and X to like plug it all in.
Okay, yeah, so that's what I would just say, the formula. If you don't know what the difference quotient is, then you don't know how to apply it, so you're pretty much stuck at the beginning. So you've got to know this. Plug in x plus h, then subtract the whole function, and then divide by h. Okay, either of the other two, I know you guys really need to try them on your own, but actually, yeah, just I'll be happy to help you if you feel like you need it. But I did not assign these two to you, but I do want you to do them, of course, especially since they might be on the test. So apply the difference quotient and try to simplify it like you did in difference quotient practice 1 worksheet. And then before I give you some time to kind of look over all of it and absorb all of it, let me speak on these resources down here at the bottom. So truthfully, just kind of person to person, depends on like what people need more practice on. Like there's probably 2 of you that could benefit from practicing some questions, some basic limit questions, or estimating limits from graphs like page 1, and then a different 5 of you, this class is small, so probably need more practice with piecewise functions like there was on page 2. But short of making everybody do 20 of these and 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 making everybody do an entire booklet and then it being busy work for most of that, I tried to make these direct links for you guys to make it as easy as possible. But you need to take on that responsibility. If there's a certain question type, like you guys asked about this one earlier, if you're not sure that you're okay at dealing with the conjugates, then it's optional. It's not like you're doing it for a grade or have anything to turn in, but you really should try at least a couple of those. And then if you feel better after you do a couple, then great, you're probably going to do fine on it on the test. But if you're still missing them, then at least you know it and you know to ask or to get some more practice in. So those are all optional, but some very, very direct practice. If you go to this link, it will only test you on that one skill. If you go to this link, it will only test you on that skill. So, okay, so if you guys would, unless you just went ahead and did it on your own already, go ahead and try 27 and 28. Check the answers with the website to see that you're getting the same thing. Those answers should be fine. And then if there's one or two of those you'd like me to go over, I'd be happy to. But then you should just do a quick little review on your own. Make sure that you're ready for these question types on page 1. That's really just one skill, so even if you completely forgot it, you can relearn it in like 5 minutes. That's what we did the very first day. Page 2, not so quick. There's a lot of different things going on here, but chances are, if you are ready for all of these question types on page 2, then that's about half the test probably. Then being able to do infinite limits, knowing your horizontal asymptote rules, being able to explain why something's continuous or not continuous using the definition and difference quotient. So a little bit of all of that will make up the test. And of course, if there's anything I moved on too quickly from, once you get there or once you're done with these two, feel free to ask no matter what it is. And or if you do some of this extra practice because you know you need some of the extra practice and you're having trouble with some of it, then I would be happy to help with that as well. So I just need y'all to tell me how I can help. But we need to test this and move on from it on Thursday.
For these, do I multiply by -4 or 4? Like
Just 4.
Okay.
Actually, if you multiply everything by -4, it would still work.
Okay. But you would recommend
just 4,
doing 4
yeah.
and then keeping the negative right here when you multiply.
So this would be, yes.
Okay, because now I don't know what to do. Because if I take out the 3, I get 4 minus x. And that's different than the bottom.
Mm-hmm. But you could still break this down more.
Oh, I was supposed to.
And you're also going to have to factor out a negative to make it look right. So again, I know things are kind of disjointed, and it may not feel like we're giving an extra day to this unit to you from your perspective, but we are. But a couple of things to keep in mind. Of course, I will pick up the review before the test next class. I think there's probably 1 or 2 other assignments that we've been doing that I'll take up. So you need to make sure that if somehow you fell behind on AMI, that you get that caught up. Probably like the difference quotient practice or something. But also any of the other assignments that I took up before, if you were absent that day or you just didn't turn it in or whatever, make sure you have that completed and ready to turn in. Because once we start the test, it will be too late for any more late credit. So just make sure that you add that as part of your study, and that's if you need to. So y'all can speak up when you find something, or I'll bug you here in a bit for some questions, either one. guys enjoy your AMI days? Nice change of pace? No? Why not?
I have 4 siblings, and both my parents were home, and my grandma was there. There were just too many people in my house. And
Could you just like go in a room and shut the door,
I
get your
should.
work done? Well, yeah, but go to a different room.
there is no room.
Nowhere to hide.
Well, I live in a 4-bedroom house, and there are 8 of us in the house, so.
Oh. Did they have to do schoolwork too, or are they too young?
Yeah.
Oh.
The youngest one is 7.
Put on headphones and work, maybe?
Yeah, I had to have my cameras on for Zoom.
Well, I was definitely unexpected. I was about ready to leave for work on Monday last week. I wasn't expecting them to call school. Okay, has anyone found anything I can help with yet? Yeah, what do you got?
Can you explain number 16?
On the review?
What's the best words for that?
Explain how rational functions horizontal asymptote determines a limit that has x approaching positive or negative infinity. Well, a horizontal asymptote, when we say something has a horizontal asymptote of like y equals 4, what that means is that the function approaches a y value of 4 as if you're like describing in behavior. So as x gets bigger, such as x approaches infinity, or the left side of the graph as x gets smaller. So another way to say that is as x approaches negative infinity.
So it goes towards that, the arrow goes towards that.
Huh?
Why does the arrow go towards X?
Oh, just because I wrote it weird. Just to the right. Because if you know your horizontal asymptote rules, which you need to know for the ACT anyway, and you know a horizontal asymptote tells you what y value your graph's approaching as x gets really big or really small, then that's why these questions 17, 18, and 19 feel like you're doing the same work. This guy doesn't have a horizontal asymptote. I'm sorry, he has a horizontal asymptote at y equals 0, so I know the far left of the graph equals 0, approaches 0, and the far right of the graph approaches 0.
And then for number 19, I know it does not exist, but like, why?
Because it does not have a horizontal asymptote. If the degree of the numerator is bigger than the degree of the denominator, then what's happening in your graph is it's probably going to infinity or negative infinity on the far right or far left, and you just have to put a lot more thought into it. So, but whether it's going to infinity or negative infinity does not exist. Is just as good as either one of those. So, but yeah, there's only 3 questions there because those are the only 3 possibilities. Degree of the denominator is bigger, so it approaches 0 on the left and the right. Degree of the numerator is bigger, so there's no horizontal asymptote, so no limit. And if the degrees are equal, the horizontal asymptote would be leading coefficient over leading coefficient. And 16 is just making sure you understand why knowing about horizontal asymptotes is now helping you with limits. Yeah, what you got?
What's number 77? It's like, the review is 78, right?
77 should be the, I think, difference quotient practice 1 worksheet.
Okay, I have myself off sometimes. I have
Let me-
76.
Hold on, I can check. Oh, I'm sorry. The review is actually 77. I misspoke. And when I had you guys do the review, I didn't tell you the binder number, so you probably don't have that number, but it's supposed to be 77.
What papers are you taking next class?
I haven't decided yet.
Okay.
Anything that we've worked on that should be completed
So
this very game.
quotients, that's about it.
Difference quotient practice 1 would probably be a good one, or difference quotient notes. I already took up the continuity. I didn't take up the review. So probably 2 or 3 of those. But I think that's the only ones I haven't taken up. But if you're missing something else, like I did take up other assignments this unit, so if you didn't turn those in when you were supposed to, you can still get late credit, but only if you do it before the test. I try to always remind you guys of that, so. Also, I don't remember exactly how many points this one is, or what we did last year, but since we're still basically in a new semester, we really only have one assessment major grade in the grade book right now, and it was only a 30-point assessment. It was that law of sines, law of cosines quiz. So even if this test is only 50 points, it's still going to feel like a lot at first. So. And we've got this unit, and I think everything else the rest of the year is algebra review, which is good no matter, unless you're doing AP Stat only next year. The algebra review is really, really needed for calculus, but it can also be very helpful for college algebra too. So. But pretty much everything we do the rest of the year is at least familiar. We just have to make sure that you remember it and go probably a little bit deeper, fill in some of the gaps that you may not have had time to get to in Algebra 2. But a lot of students prefer that since it's familiar at least. Okay, I'll bug you all for more questions here in a bit, but again, feel free to speak up at any time. Alright, before I take a few more questions here, if you guys have more, I do need to tell you about, we have the ACTM math contest coming up. If that is something that you're interested in participating in, there is a deadline, and it does cost money to sign up. It's $5. But it is something that does look very good on scholarship applications and college applications. Unfortunately, the last few years they made it a little bit more convenient for us where we could do it here at the high school because of all the COVID stuff. But this year it will be back to normal, which is at the university, and it's like March 8th, I think. March 4th, and that is a Saturday, which I know is not the most convenient, but I know last year very few people participated. In fact, I think only 2 people participated in the pre-cal one, which is actually very good, because even if you got none of the questions right, you could still say that you were second place at Fayetteville High School that year. So I don't know how many people will be interested in signing up this year, but it is something to think about. So if you're willing to do that on a Saturday morning, if you're interested in doing that, that's the regional exam. If you do well enough, then they invite you to the state exam, and if you do well enough on that, you can win a small scholarship from it. But just wanted you guys to be aware of it. Also on my website, if you are going to do it and you want to practice and aim to be competitive, just a few years ago I actually had a student that won first place in state, so it is definitely achievable. But the test is not exactly what you would think it would look like. The problem with pre-calculus is some schools do things in different orders, and they don't make the test based on the order that Fayetteville High School does it in. It's a regional exam, so there'll be people from Farmington and Prairie Grove and West Fork and Springdale all there to take it. And Springdale may have already done exponential and logarithms, and we don't do that until next. And Farmington may have done conics, and we don't even get to conics. We run out of time before we get to that. And the test has a little bit of all of that kind of stuff. But I haven't updated it in a long time. But if you are interested in practicing and preparing and trying to be competitive, on my website I do have, here's pre-cal ACTM math resources, and just kind of talks about the layout of the test, although I don't know, they may change it because stuff has changed. But then I've got a bunch of old tests, a bunch of old regional tests, a bunch of old state tests that you can download and see what they're like and see what it is you don't know that you might need to know, and it's got solutions with it and all that kind of stuff. So I'm telling you now, because if you're interested in doing it, you need to sign up as soon as possible, like the end of this week, the start of next week, ideally. And I can't sign you up until you pay the $5. That's not the high school trying to make money off you or anything. That is the fee that the university charges. So if you're interested in it, get the $5 together and get it to me as soon as possible, and I will get you signed up. Okay, so other questions? We're down to about 20 minutes here. Julia?
Maybe number 27 of the difference quotient.
Sure. So first 2 steps still going to be the same. You still got to know the difference quotient, and you have to know what the difference quotient is asking you to do, which is plug in x plus h the first time, subtract the function next, and put it all over h. What makes this question different than 26 is it just doesn't simplify the same way. Up here, we got to FOIL and distribute and combine like terms and eventually cancel out an h. Here, there's nothing to FOIL, there's nothing to distribute. Well, I mean, I guess you can distribute this 5, but there's not much that you can do. So you have to know this step to move forward. And it's kind of good. I think it's good for y'all to see this again, because it was just like a week or 2 ago that you guys had not seen any real uses for conjugates. So in this question type, you need to multiply the top and the bottom by the conjugate of the numerator. So notice all I did was change the middle sign from a minus to a plus. Then when you multiply these messy fractions together, the denominator is easy enough. We've got h times all of this stuff. But the numerator, you definitely want to FOIL these two terms times these two terms, because a lot of stuff's going to simplify. The square root of something times the square root of itself is just going to be that something. And I'm going to go ahead and distribute the 5 now. Actually, I'll go ahead and put it in red so you can kind of see a little bit better where it's coming from. You can take the outer part of FOIL and the inner part of FOIL and write those out, but those are going to be equal and opposite, and they're going to add to 0 anyway. So for convenience, I don't want to write all that mess out if I don't have to, so I'm going to skip that. And then the last part of FOIL would be these last two. Square root of 5x minus 6 times the square root of 5x minus 6 would be 5x minus 6, but one of them is positive and one is negative. So all of that is negative, not just the 5x, the whole thing is negative. So there's not much we can do with our denominator, so just kind of carry it along for the ride. But the numerator, we can combine a lot of stuff. This would be 5x. When I distribute this, this would be minus 5x. Minus 6. When I distribute this, this would be plus 6. And just like the other question types, the very, very last step should be undo times h with divide by h. And so your answer should be this, 5 over all of that stuff.
Is there any way to check these type of problems? Like, can you check yourself, or is it just like yourself?
Not really. I mean, there is a little bit of patterns to these. Like the fact that this was a 5x told me that this should be a 5 at the top. And then the bottom is always going to be the conjugate that always gets multiplied by it. And then like on these, I think if you multiply these two, is the answer to this negative 12 or positive 12? Okay. It's like if you multiply these two, it gives you your numerator, and then your denominator is like the thing that you multiply all your fractions by, I think. So yeah, if you want to memorize the pattern recognition part, then I guess you can kind of know what you're aiming for, but short of that, there's not really, unfortunately. Question like this, what I'd recommend you do on your test is just do the question, get an answer, move on, and then when you finish everything else, come back, look at your work, try to look for careless arithmetic mistakes, or if your answer just looks really bizarre, if it looks like you're pretty sure it's not correct, just force yourself to redo the question like on a different page, and then compare your work and see which one you are more confident in. Okay, somebody else have another one? And I don't know if I said this in the video or not, but when we do this, even though this is a calculus idea and a calculus concept, because it builds into what a derivative is, and about half of AB is on derivatives, like literally the whole first semester besides 2 weeks of limits. We don't do this all semester long. I don't want y'all to like not take calculus because you think we do this 1,000 times. We have a bunch of shortcuts to figure out what the limit's going to be, or what the derivative's going to be without going through this, which is basically the definition of a derivative. But it is important to like understanding what a derivative is and where it comes from. So we do it like one day in notes, but then the rest of the semester we just use some shortcuts to find derivatives instead of doing this.
Would you mind doing number 28 as well?
Sure. Okay, so I'm still going to plug in x plus h the first time. I'm still going to subtract the function the next time. And put it all over h, because that's what the difference quotient tells me to do. Now, unlike the polynomial, there's nothing to FOIL, distribute. I guess you can distribute the 4, but that's not going to do much. And then unlike the last one you just asked, there's not square roots in here, so multiplying by conjugates doesn't make sense either. So this is just a different question type. For this question type, you've got smaller fractions within a bigger fraction. So this is what I would call a complex fraction. So you should simplify it the same way that you simplified the complex fraction on page 2. You should want to multiply this by 4x minus 2 so that it cancels that out. But you can't just multiply one of these by 4x minus 2 without multiplying them all by 4x minus 2. And you should want to multiply this one by 4x plus h minus 2 because it cancels that out. But you can't do that unless you're willing to multiply all of them by that. Most complex fraction questions get really messy here, so you need to be very careful. But it looks like what's left over from this part is negative 3 times 4x minus 2. Don't lose this negative sign. What's left over here is 3 times this stuff. So 3 times 4x, 3 times 4h, and 3 times negative 2, all over this stuff in the denominator. And then if you remember how to do that and remember to do that, then now it's going to finish like the other questions. Combine your like terms. Everything goes away except for the h stuff. Undo times h with divided by h. That's always your last step. So the answer to this one was 12 over what you were multiplying all the fractions by. So this was where I was saying as a check, if you multiply these, I wasn't sure if it was 12 or negative 12, but if you multiply these times a negative 1, that's what your numerator should be, but your denominator would be what you end up multiplying all the fractions by. To make it not be a complex fraction. So that's the closest way you can check that.
Thank you.
So 2 question types you need to be able to simplify complex fractions. Compare 28 to number 12. Number 12 is also a complex fraction. It's got very similar steps, even though they're different questions. And then 2 of them needed conjugates. Number 8 and number 27, I think. Both deal with multiplying by conjugates. And again, even though we're doing this to give you an introduction to calculus, multiplying by conjugates is an algebra topic. You need that for college algebra. Simplifying complex fractions is an algebra topic. You need that for college algebra. It's just that in Algebra 2, you typically don't have much time to get to those things and practice on as much as you really should. So, still good algebra practice. Okay, with 10 minutes left, anybody else got anything ready to go?